All right. Well, we're going to be going into 1.3. And in this 1.3, we are talking about the measures of center and variability and how you determine what to use in different situations. We talked about this a little bit in 1.2 in one of my other videos, but to be a little bit more specific, we're going to talk about, give you some notes, and then also go through a problem or two. So here we go. First off, measures of center. One of the things when you talk about distributions is you have to identify where the center is. And there's two main ways to find center. There's one way of finding and using what's called a mean or average. Typically, when you talk about a mean, what you call is this right here. And we call it X bar, all right, X bar. And so when you have X bar, that's referring to the mean. And how do you find the mean? Well, you've done mean pretty much all your life, at least I think you have, probably in grade school and whatnot. You use a sigma, that means the sum of. You take the sum of all of the different values you have in your data, and you divide by that total number. And that's what that means. So you sum, sigma sum of all the values, and then you divide by the number of x values that you have, all right, total number. And that's what we have for mean. Now, median is sometimes referred to as big M. Okay, big M. It is the middle value of odd numbers of a value, and the average of the two middle numbers if you have an even number of values. Okay, so total number of values, I should say, values you have. Okay, so that's how you figure out what center is. Okay, so it's either mean or median. Now, measures of variability or spread. Now, normally, if we don't have, well, how we do this is this way. We can use what we did before is known as range. Range, we take the max minus the min, and that gives us a range. And we did that in the previous examples. Another one that we want to do is IQR, interquartile range. We're going to do that in the next lesson. But in order to figure out this, you're going to take Q3, and I'm just going to write that down, Q3 minus Q1, all right? Yeah, Q3 minus Q1. That's how you find your interquartile range. The standard deviation, also known as little s of our variable x, is the square root of the sum of the differences of the difference between our value and the mean. We take that difference and square it, so we just have a positive number, divided by the total number of values minus 1. Total number of values by 1. And that's how we get our standard deviation. Now, what is the standard deviation? Well, if you see this right here, and you went through, and if you were in my class, we would go and test this out so we understand standard deviation a little bit better. But what it is really, it's what, in context, whatever you have, what typically varies by whatever the standard deviation is from the mean of whatever that number is. So it's essentially how the values typically vary from the mean. Okay, how the values typically vary from the mean. And that's what we talk about our standard deviation. It's a spread of that data. Another thing that we should know is when you have whether something is skewed or whether it's not skewed, how does it affect the mean and standard deviation and so on and so forth? Okay, so first off, mean and standard deviation greatly affected by outliers. So that's the first thing. You have to know that mean and standard deviation are affected by outliers. So that's whenever you have skewed data, all right, we do not want to use mean and standard deviation, but instead we have median and IQR. We use it whenever we have outliers or skewed data. Because we would say that that is non-resistant. Okay, sorry, that would be resistant to outliers. Okay, these are resistant to outliers. Okay, those are resistant outliers. Mean and standard deviation, we would say, is non-resistant. So they are not resistant. They change when you have outliers. They may either come in bigger or smaller depending on where the outliers are located. And so we only use median and standard deviation when we have symmetric distributions. Okay, symmetric distributions. So when the distribution is skewed, okay, median IQR, when the distribution is symmetric, we use median and standard deviation. Okay, so those are some notes on how we measure center and spread of different distributions and how they are affected by the distribution. All right. So we're going to go through some other examples in just a little minute. So take these notes and we'll see you in a bit.